All right, let's go. Voice good? Yep, looks good. Mic good? Okay, good. All right, let's go. Yesterday I had to move some shit because I'm moving apartments. And then the day before, I was doing some Unreal stuff. Okay, more arrays. Standard array specifically. Excuse me. What? Jesus. Okay, IntelliSense is insane now. Not yesterday, but the day before, I was working in Unreal Engine. I'm trying to edit some guy's repository, his plugin. I'm trying to edit a guy's plugin so that it handles voice recognition at the character level and not the world level. Because right now, if you have two characters in the world and one casts a spell, the world tells both characters, or well, in one player speaks, the world handles speech, and because the world is handling it, the world says cast fireball, but it tells everybody to cast fireball. And the only solution is to make it so that instead of speech being handled at the world level and captured at the world and sent to everybody, it's captured at the player level, so it's only sent to the player. That way, player A says fireball, player B does not cast fireball. It's only player A that does. But in doing it, I was building my Unreal project, and there's a whole shitload of files here, and all of them basically say failed to load. And I constantly, when I'm in the files, there are red lines underneath, like I haven't, like this. Like this. And it would say, oh, it's undefined. Well, in this case, whatever. But it would say, oh, there's all this code here that's undefined, even though all the proper header files are included and everything looks good. The reason is because there's some sort of, oh, and this is not standard character output. This is totally standard array. Hello? What is happening here? All right, what am I seeing? Wait, am I going retard mode for a sec? Hold on. Oh, duh, I don't have, you can't just specify that. That makes sense. I was specifying, wait, I guess I hadn't built before. It needs to know how many there are. So if we don't give it an initializer, it 0 initializes 1. Okay, that was just stupid on my end. I hadn't done this in 2 days. But I had to go into these environmental variables in Windows. It was just a Windows setting, and I had to make it so that some .NET thing, I don't really know what that is, some sort of functionality of Windows, I had to reorder it. There are 2 of them. I had to put one before the other, and that fixed it. Everything builds properly now. And IntelliSense works perfectly, and that's all I changed. I don't know why, but I mean, like, include array, and it tabs to autocomplete, and right here, it just does that. I don't know, it's just crazy. It's never done that before. So I don't know. It feels cool though. I mean, I like the predictiveness of it. It's gonna help in Unreal because in Unreal there are just so many different things that I need to remember. Like what the parameters are, and I don't know, it just seems like, I guess I don't really care about the prediction part. I just care about the errors not happening anymore. All because of some .NET thing that I'm assuming everybody's on Windows 11, and because I'm on Windows 10, it didn't get updated. So I'm just left behind a little. Okay, and so we're about to talk about standard array or arrays of references. And I think just standard array, not standard vector. And honestly, I'll keep this liked, but I'm not going to add this to a playlist. That was okay. but that's kind of all. All right, so if we have int x is 3, and then int y is 54, sure. And then we'll make this guy called, this array be called z, and it'll get x and y. Oh, well, duh. We're not, we don't have, there's no reference yet. Okay, let's do, actually, let's do int x reference is, this is an int reference to x, and this is x reference. Okay, this is interesting. Oh my god. Okay, that's ridiculous, dude. The prediction. Oh my god, it's already filling in which index I want? Okay, that's ridiculous. It just knows. This is a crazy feeling. But then what if we change XR, whatever, we'll do 4, right? And then we're gonna, oh my god. Okay. And so I think what's happening here is I think, what the fuck? Z is no. Oh shit. Okay, this is crazy. It's like some schizo. I don't know. It feels really weird. I've never seen this before. I think Z is copying the value of X. Oh shit. The value of XR, which is X. It explains why oh my god! Is this Copilot? What is this? Okay, I need to find Copilot and turn this shit off. Is that what this is? Oh, maybe that's what that was. It must have been Copilot doing that, huh? I feel like, I don't know, I kind of like this better. I'm just happy that there aren't errors now. It felt like there was this extra thing that was competing with me. And it's, I mean, it's interesting. If we enable Copilot complete, does it, nothing? It doesn't show me anything? Okay. It is the Copilot, okay. I'm gonna keep learning myself. I really don't, I don't want to use any AI stuff. CP, how do I even, I want to just disable Copilot. No. Alright, you know what? Well, fuck it. I'm not gonna stop recording. I'm just gonna, I'll do that. Oh, wait. I think I could have actually just done it there, but we'll do, oh, wait. I think it's Visual Studio. Installer. No, Visual Studio Installer. There it is. Modify. Copilot. There we go. Should be easy enough. I don't actually want Copilot. I want to go and dig deep and understand all of this. I don't want any prediction. I don't want any autocomplete. I want it to just be me. I want to expand my brain because, I mean, it's not like muscular development where if I'm getting fatigued, I can have somebody help provide resistance so that instead of me completely dropping it, I'm still fighting a little, just the smallest amount possible. Like I don't have a weight that's 1 pound less to get every inch more out of me. So someone else can help. So I can get every possible stimulus into my arm. But here, it's not like, oh, I'm going to be so fatigued with programming and I'm so dead asleep and I can still function with autocomplete. I just don't like it. I want to, I swear my memory has significantly, it feels like my memory has improved, subjectively or not, or objectively or not, it feels like my memory has significantly improved since trying to learn how to do programming, or at least C++. Because it's like it feels like my brain is just more capable of remembering things. I mean, I can answer questions on all of these topics and all of these different things that I had no fucking clue about at all. I mean, I would say pretty fluently as LearnCPP teaches you. So I don't know. It feels like if I let anybody else do that learning work for me, then it will detract from the benefits that I'm currently reaping. So I'm going to just tap out of AI. I'm just going to do it myself. And regardless of of how accurate any studies might be, let's say, well, let's just say, what is it, like brain, I don't know, not brain fatigue, but like, is there a percent of brain power that using AI in an instance reduces? So if you're going to search something and try and remember it or try and figure it out yourself, if you had used AI, how much less energy are you using, or how much less are you doing? I don't know. We'll do anything crazy here? No, we're cool. Oh, great. Hello? Still, damn. Cognitive effort. That's a good way of explaining. Let's see. Less cognitive effort on tasks. Reduced engagement of memory, analytical, and reasoning processes. And it seems like to me, as AI increases, if we're as rigorous as we possibly are, even with AI, then I could see that humans would continually still get smarter and still be doing things. But if our effort decreases as AI continues to get better, it seems like at some point we may as well just set AI loose on itself. Because if we continually decrease in the amount of cognitive effort that we're doing, it seems like at some point AI would just surpass. It would finally, even if AI is down here and we're talking about our actual intelligence, if AI is way down here, but it's still helpful because we don't have to use this lower level information, AI just auto-populates it like IntelliSense there. Excuse me. Even if AI is getting crazy better, if we start dipping at all, it feels like at some point there's going to be a merge, and at that point we may as well just set AI to do it, and humanity won't keep up, or I don't know. I don't want any negatives. Basically, I don't want any negatives. At least in terms of my memory or my ability to do things independently. So if I lose AI, then it just feels like something I don't want to rely on. Like if we lost the ability to compute, I could still figure out logical strategies to solve things and figure out conditions and have better problem solving. and we could get computers back up and running. And if there was some sort of rudimentary programming language, that experience would be helpful for me. But using AI would not be helpful, I don't think. A prompt engineer. Oh no. Okay, this is just insane. This is writing though. Experience higher satisfaction, but deeper. Oh, here it is. Higher satisfaction, but deeper learning, memory integration, and creative thinking are diminished. Because it seems like it's like if I had the lead writer on my development team for a lead writer on my video game, and she starts offloading some of her effort onto some lower level writer who's newer. I feel like I probably don't want that newer writer doing the majority of the work. I don't want the main writer to be like, oh, okay, I'm just okaying the stuff that you're writing. I want her to be coming up with the meat of the story. And the underwriter or whoever to be supporting, checking, basic little editing help or whatever, rereading, just another perspective. I don't want to offload that because every time I press tab with Copilot completion, every time I press tab is work that I am no longer doing. But programming should be thinking and finding ways to solve problems and do things. And those parts I don't want to be diminished. It's also maybe some repetitive shit and syntax and forgetting semicolons and other stuff that just make the language work. It's just a means to an end. But pressing tab solves both of those. It fixes, it automates boilerplate code. It makes it just happen. Like earlier, Copilot got what I was thinking exactly. But then I don't have to fully flesh out my thought. It's like I'm thinking about something and I haven't fully fleshed the thought out, and then it gets fleshed out for me. And I never get the experience of coming to the final thought and running through my whole train. I just see that and then I just grab it, but maybe the real thought is actually behind it. And if I had kept thinking about it and not just grabbed the low-hanging fruit, I could have grabbed the real tasty fruit and not the one that goes old quicker or just isn't the right fruit, isn't right for me, you know? Okay. So, reliance on AI, cognitive offloading. It seems like that's the case. I mean, this part, too. I like this. I admire people, chemists and whatnot, who can just remember who did what in the field and say why. It's because of this repeated exposure and fighting with the information. It feels like, it might be incorrect, but it seems like IntelliSense is faster right now. Oh wait, bro, why did I just make a nested int main? Oh my god. Right, I'm already cognitive offloading. I don't even know what I did just now. I don't even remember. Okay. Arrays of references. So what's the issue here for saying arrays can have arrays can have elements of any object type, but we know that references aren't objects, so that'll be interesting. I think they said that they could technically be objects in some cases, but I don't remember which. Fundamental types, compound types, like a pointer. Okay, makes sense. Yeah, so I could have an array that has a bunch of things. So you could have like a like what? What could we do? We could have an array, and we could have a class, and we'll just call it person, and then we'll say we'll just say I don't really need a class, do I? Well, I'll just make a constructor, sure. We can return a standard string because it's movable with move semantics. And so we could have a standard array of standard strings, and we'll say, oh, we don't even necessarily need to. We could actually just say, we could say that there are people. So there's people. And let's say there's a okay, there are two people, and we're going to make a standard array. I'm not going to put in standard string. It's a standard array called targets, and it's initialized with people Fred and people Jessica. Okay. Well, and what's the point here? Oh, the pointer is that we could have I could get the address of both of these, and now this is holding, and these could be, let's just make them const. So these are both pointers to const standard strings. Yep, there it is. Or, let's see, yeah. Specifically, it's a pointer to a person, but a person, well, actually, okay, that was incorrect. This is a pointer to hold, yeah, a pointer to const. These are pointer to consts. What are they pointers to? Const persons, which happen to be standard strings. So we can't change these. We could do like, I mean, I could dereference targets 0. And then if I wanted to, we could do like, it's upset because we're discarding the return value that's marked as no discard. Hold. This is the reference. Oh, we don't have a way of outputting a people. Yeah, just doesn't match. And in this case, I'm gonna teach standard operator insertion to do this. So now we can store not only objects, well, not only fundamental types, but compound types like pointers to objects. But if we instead had we'll say person or const, we'll say person reference Fred R, and it's initialized with person. Well, the problem here is it's going to need to be a const person reference, person Fred, and then const person reference Jessica R, person Jessica. Hold. Oh, sorry, not person. Jesus, what am I doing? It's people Fred. And people Jessica, not the class, it's the namespace we're looking for. I was just being stupid there. And this no longer needs to be dereferenced. This now just needs to be Fred R and Jessica R. So we could do this, or we could do something like for const auto reference value, or we'll say element targets element. Okay, so now this will print both. But we could make these non-const now. And we could say, we could just make this a function, but it's fine for now. And now we could say targets 0 is now person. Okay, so now his name is Jeff, and targets 2, or well, the second index is now person. Okay. Then we could do the same thing. We'll just do a little for each loop, print them out, and we'll see no change. Oh! Oh wait, because the point is that the array is copying this by value, and I can change this and change the values that it has here, I think. So actually what should have happened here is we know that the array is updated, but now we need to output. Ow. People Fred and output people Jessica. There it is. So Fred and Jessica, but then we update the array, and then we check Fred and Jessica, and we see that the array was updated, but Fred and Jessica were not updated. So even though the array was storing references apparently, or was initialized, its members were initialized with references, and maybe we can test what happens here if we say person reference 2. Oh, it does say it's okay. It's interesting here. Does it stop me from building? It does stop me from running. So it seems like there's an issue there. 10 of them. And it might be, I'm trying to think of what the 10 might be. Maybe we get 2 errors, one for each reference we're trying to put in, and then another one because we're trying to put references in a standard array anyway, and then more because we're trying to use the array, and then 2 more, so we're at like 7-ish. And then, yeah, I could see there being about 10 errors. So fundamental types and compound types can be stored in arrays. Okie doke. What if we did the same thing with standard vector? So now here's this. But same thing. Jeff and Marissa, the array has been updated, but not the values that were used to, or not the objects that were referenced when initializing the array. So it seems like the array might. Let's see what the array looks like. What does IntelliSense say that the array is? Yeah, see? It's holding person. It's not holding a person reference. So if we look at Jessica, in here, we see that, hey, these are references to person. These are reference variables, and they're person references, non-const. But these are not person reference elements. These are person elements. Okay. Ah, freaking foot stitching. Why? I need to turn a light on. Okay. Yeah, I'm gonna do the window too for now. It's early enough. Okay. Okay, turn the light off. I don't want both on. Jesus. Oh, and we actually okay. So we're doing arrays of references, even with both types here, array and standard vector, standard array and standard vector. So we have two integers, and then we're initializing the standard array with these two integers. So we say value array, so values, and then we have a standard vector of pointers, and that's because when you do the address of operator before the right hand binary, what do you call it? The binary operand, which in this case is just an object. Well, you get the address of that object, but really it's returning a pointer to that object. It's not literally returning the address because you can't print that. All right. And actually that might not be true. I don't know if that's something in there was like, it was like you can't convert it in a certain way. I thought you could still, let me try this real fast. I'm gonna say in x 0, or we'll just do 3. Oh, it's actually okay. Okay, so you totally can print the address. There was something in there semantically that it wasn't a number that we could do. Like the address operator was returning. I think it was something like if you get the address of something and you tried to convert it to an integer, it either wouldn't convert, or if you converted it or casted it to an integer, so you explicitly converted it, and then you passed it to a function that took a pointer to an integer, then it wouldn't work because you were actually passing the number and not a pointer to it. Something like that. Like the pointer isn't actually the address, but it's an object that holds it. It was like a gnat on the wall or something. It was like a little piece of black. Okay, so we have an array of values, integer values specifically, with class template type or class template argument deduction here. And then same thing with the standard vector, but this time for pointers, because we're using the address of x and the address of y. Okay. References aren't objects, so you can't do that. So the elements of an array must also be assignable, assuming it's a non-const array. And the point here is that if they are references, then we can't assign anything to, well, we can't reassign them to be, so it's not, the elements must be assignable, meaning that, well, maybe, is there some sort of incompatibility there? Like if we have an array, the element needs to be able to change what value it is, meaning it needs to look at like a different, well, okay. References aren't objects, and you can't make an array of references because of that. All right. Array elements must be assignable, and references can't be reseeded. I mean, they can be assigned. You can change the object, the referent, through the reference by assigning value to it. But the point is you're not actually assigning value to the element. The element is still just holding one value, which is the address, a dereferenced address, basically, of the object it's bound to. So if we make an integer and another, we create a standard array that holds two integer references, and we call it reference array. No, sir. And if we create reference variables, and then we do standard array, makes sense. Yeah, that's exactly what we saw. We saw that if we made references, and actually same thing here, if we passed in the address of x and the address of y here, or I guess pointers to x and pointers to y here, class template argument deduction would not deduce int reference and fail compilation. It actually deduced integer. So it's okay if we let class template argument deduction drop the references and say, no, sir, we're not doing that. It's not okay to explicitly say, hey, this is a standard array of integer references. Nope, not allowed. Not an array of references, okay. Reference wrapper, huh? And behaves like a modifiable reference to T, and it's okay to use what? So we could have a standard array of two standard reference wrappers, maybe? And class template argument deduction would deduce that it's a reference wrapper, maybe? Fuck. It wasn't utilities, it was, fuck, what? I don't remember. Functional. Oh, I would not have remembered that. So we could make integer x 3 and a standard reference wrapper x reference to x. Huh? Oh shit. And then we can make a standard array and just call it int ref array. And initialize it with XR, and class template argument deduction deduces that this is a standard array of reference wrapper. Yep. Oh, of reference wrapper int. I wonder if IOStream is already, or if standard character output can already print a reference wrapper. Seems like so, maybe. No? Doesn't match the operand? Okay. So we'll say, well, I guess it needs the type, huh? So we need a class template? I think we do. Well, hold. We need to, so what do we have here? Do we have like ref dot, oh, we do have get, okay. Cool. All right, so we can do output. I was gonna say, because if I can't print a reference wrapper, then I can't just plug in reference wrapper to output device. I actually have to get it. So we'll say output device, inserting to it ref get and return output device. Uh-oh, hold. Oh. Wait, hold, we still haven't... Oh, it's not, that's not the issue. The issue is the fucking array. Duh. Okay, I actually don't think I need to do this. We need to do array 0. Okay, so you can do that. Nice. So it seems like standard character output already has an overload, or the insertion operator already has an overload. Maybe. Already has an overload that prints the .get, so we're cool here. But then, what if we change int ref array 0 is now 4. Uh-oh, hold. Is it going to say that you... does it treat it as const? What happens if we try and do this? What if it said xr is now 4? Oh, we can't do it. It seems like it treats it const. Or is it xr... Well, is it int ref array set? Or no, .get? Okay. Still no. Okay. Oh wait, not, oops, sorry. This is 0, get is now 4. Hold. Int ref array 0. And then the question is if x becomes 4. X does become 4. Oh shit. So x is 3 at first. And then we get a reference to x. Wait. Oh, okay, here it is. So we have x. We get a reference to x. We initialize this standard array with that reference and print it. So it should get whatever value x has, because that's the value that xr is bound, or that's the object that xr is bound to, so it should be printing that object's value. And we print it, cool, 3. But then we assign the get, we get that reference, or we get the object through the reference wrapper and assign it 4. And then we print and we see, oh shit, it did change the value in the array. But when we go back to the object, we also see that it changed the value in the object too. That's cool. Few things worth noting. Operator insertion will reseed it. Interesting. So it doesn't behave like a regular reference. It's reseedable. It's like a I mean, it's like a reference that can be reseeded, right? And so it's like a pointer to something that you can't evaluate conditionally, but is automatically dereferenced, which can be scary. Implicitly converts to a T reference. Used to get a reference to it, huh? This is the same shit I was just listening to. Hello? Well, oh, so if we Oh, so this probably requires an object. So if I create int y and say it's 5, right? And then we try and just assign this guy here. Doesn't work, but here it works. Okay, so a reference wrapper must be assigned an L value. It can't be, because it needs an object it can bind with. And if it's const, then okay. So we can indeed reseed it by binding it to something else. So I could have this array, and this element is bound to this other object, but then it can instead be set to be bound to this other object. Okay. And yeah, so we can print it without having to do the get. We do the get to change the value of the bound object, and we use the assignment operator to change which object is the element or the standard reference wrapper is actually bound to. Okay, cool. So we could do a reference wrapper of int, or just do type deduction if we pass it those as addresses. Or no, no. What? Oh, we could actually receive them as references, so we don't actually need an XR to be put in. Okay, interesting. I don't need to create an independent standard reference wrapper. I could just create an array of standard reference wrappers, and I can pass objects to it, and it will bind each element to the respective object. That's cool. So X, Y, and Z, so we get 1, 2, and 3, and then oh, and then we can change Y to be 5, and then we can print 5. Hold on, why is it printing 55? Oh, we're printing element 1 and also printing Y. And so the point here is Y is 2, and we can use get to change the object. Okay, gotcha. So we're assigning two things at once. So we're basically just updating Y through the reference wrapper to Y. And if we print the reference wrapper and we print Y, we get the same shit. Okay. Because otherwise, if we do array 1 is 5, we're trying to assign, it sounds like an R value to a non-const value reference. Or whatever the hell a reference wrapper really is. Cool. And I wonder what makes things convert like this. Is it just an automatic thing and you would have to make it explicit to make it not convert? I'm not sure. Like how you define whether something can implicitly convert or not. Got tired. Oh, let me do one thing. Oh, it was scary. I'm good. I forgot that I should be fine because I don't think the apartment is managed on Saturdays. Moving to this new apartment and I have to pay my rent in checks, which means I actually have to transfer money to a checking account, which I've never really done before. I mean, like I don't know, like a couple times I've needed to pull money out of a fucking debit card or something, and then I had to do it right before then, like getting cash. But that's it. I've never actually had to regularly do this, so I just had to put some money in a checking now, which is annoying. Cause I don't know when the check's gonna get cashed, and I don't get interest. Excuse me, or as much interest on the money that's in the checking account. So it's like slightly handicapping, but it's fine. Okay. So something is letting standard reference wrappers implicitly convert to a reference of an integer. So it implicitly converts to a reference of the type that it's holding. Okay. Hmm. What is cref? Constref? Bro, what in the fuck is that? Auto ref 2? I guess instead of doing, yeah, fine, I guess. Because I guess that's technically a standard reference wrapper of a reference wrapper of an int. Oh, Lord. And const. And so does the const part mean that you can't change it through it, but you can still assign? So you could assign to it, but you just can't assign to the get? Or is it the other way where you can change the value, but you can't reseed it? Is const reference acting like a pointer to const or a const pointer? Can be used with auto. So we could say an int x, and then we could say auto ref, auto c ref. With ref and x, okay. Reduces to reference to const. Okay, so we could reassign it, I think. We just can't. It's like a constant pointer. We can assign the pointer to point to something else. We just can't change the integer object through the pointer. So a const reference is basically a pointer to const, just dereferenced automatically, or just pre-dereferenced. I need more music. I'm just so fucking tired today. Okay, I kind of want to play Armored Core at some point. Is this any good? It's not bad. It's just too slow for me. There's not enough going on. Is this any good? Oh, I like that sound. Oh, there's a lot more going on. I like that. So we could also do standard ref instead of a standard reference wrapper in. Meaning, so we, and is it still within functional? Or like, I'll assume it is. Does this work? It does, okay. Oh. Oh. You call ref and it just returns the const expression reference, or it's a const expression function and it just returns a reference wrapper of the type you're giving. So, okay, interesting. It's just faster, it seems like. Oh, so you could put in the type for ref instead of having to, okay. Oh, isn't it? So is it auto and it's standard ref of this? Ay. So standard ref is just a faster way of getting. Okay, interesting. And we can make it const auto to treat it like const. And we could also do cref. But if this was const, we probably couldn't do regular ref because then it'd be treating it as non-const. Uh-oh. Oh, but it's still deducing the type of constant, so it's not going to return. Okay, cool. So it doesn't drop const. Okay, that's cool. Could also just do that instead of having to pass it. Okay. What if we do some nested shit? What do we want? How about an x? Give it a value. We'll do standard reference wrapper int xrx. Okay. But then what about a standard reference wrapper of standard reference wrapper of int xrr xr? Hey. Can I do it again? I just want to. Standard a reference wrapper. Oh, or we could now do an auto hold. What if we did auto? What if we did const auto? XRRR. And it's standard ref. What's the point of standard or cref versus or well, let's just do the same thing. Hold. Oh. So what if it's const? Hold. Oh, that's the problem. I don't actually want to specify the type. So yeah, both work. The difference? It's treating it as a constant. Okay. So if this guy is a constant now, then they will look the same. They're identical. Okay. So cref will add ref to it, but not drop it. We'll add const to the reference, or const to the. It will serve as a const reference to the object, regardless of whether it's const or not. But ref will add const, or we'll keep const, but not drop const. So ref is always safe, but if we want to treat a ref is always safe if it's non-const or const. But if it's non-const, it will let us modify it. Okay. With the .get. Okay. Since ref and cref are short of the type, they're still widely. Oh, wait, hold on. Could do that. Still widely used to create them. Okay. And the point is, you would do auto ref to do. I don't like auto shit, bro. I don't like it. I'd rather just see that, hey, we're making a standard ref. I'm on that zig grind. Yeah, this is good. What about this? What about the rest? Let's critique some more. Let's do this. Let's try this out. I thought the art was pretty cool. There. Oh, that's weird. Oh, hell no. No lyrics? Yeah, I was gonna say this feels like a dude's music. Bro, how about you use your fucking brain? Hold. Isn't that? I'm gonna be mean. Fuck it. Oh, this is good. Very nice. Standard array and enumerations, huh? Wait, didn't we say that standard arrays, or it wasn't LineCpp saying that it wouldn't work with enumerations? Was it that it was well, not references. It wasn't treating them as reference. I'm trying to remember. I thought there was some sort of concern with using them. I mean, we were using enumerations as the index because one, they're already unsigned, which is cool. But two, they add value to what we're indexing. For example, if we have a class of 5 students, we know the 5 students. We may as well make an enum with 5 names and maybe 6 so that we can say for in loops while it's less than 5, 0, 5, right? That way we can actually say, hey, plug in Dante into the get grade or get student's grade instead of plugging in 4 because he's the last guy in the class. Right, indexing and length. Yeah. Const expression standard array. Yeah, because we know that enumerations are done at compile time, so oh, the point is, yeah, if we have a const so we have a const expression array, the values inside it have to be known at compile time, right? Which means, so we have an object here, not a function. And if we index it with enumerators, then we know that everything must be evaluatable at compile time. Does that mean that we can then, what, not have to loop or make things more efficient? I'm trying to see what's happening here. I'm just tired. So what happens if we had a function that, well, oh, I guess we're not going to output it, but so we can have some big loop that, but the function would need, the function would need compile time values to do this, but if we knew, if we had a pathfinding algorithm that happened at compile time, let's see. Well, I guess it would have to be deterministic if that's the case, right? And wouldn't the seed be non-variable? Meaning that we wouldn't be able to change it because it's not something that's found at runtime, like standard chrono steady clock that's found at runtime, or rand. I don't think rand is compile time. Let me find that out. Let me verify. Is rand, or not rand, random device? This is not what it is. It's the fucking, it's just random. Oh shit. Okay, this is interesting. Now what if we say hold what do you say static cast to an int? No? I'm not sure what the return type is. It returns, or what does RD return? Oh, we probably can't because it's compile time. Fuck. Because it affects the seed when you call that function. Damn. Okay, I was hoping that if we could make a const expression random device, we could run it. We could calculate a bunch of random numbers all at compile time instead of having to do that at runtime, and then we could have things in arrays and store those random numbers in a const expression array because we could use those results as initializers, or we could take an array like the people in the const expression array and change their values and randomize them every time the game starts at compile time. So there's no actual calculation cost. It's just at compile time. It's already done. You might need a cleanup though at the end of the program closed though. That way, if you want behavior to be random every time you start the program, then you need to change the start of the seed. Unless rand's values change at every time you compile, which I doubt. Okay. So no luck there. Static assert. Oh yeah, we already knew that. Oh, but the point is now we could say we couldn't use a static assert before, huh? Isn't that right? I know I'm doing static assert and that's already included in base C++, but I want assert too. Do we need anything else? Include array. Okay, it is assert, not standard assert. Alright, good. And I'm gonna do an enum, and we'll call it Pokemon types. We'll call it Pokemon type. And so we could say standard array. Let's just say Pokemon in world of type. And we'll say there's fire, water, metal, ice, dragon. So we'll just say there are 1, 2, 3, 4, 5. Okay, and then we get assert that Pokemon in world of type size is max type value. Cool. But now we could static assert this. And we don't need assert anymore. We can do the same thing. And now if this was less, it'll fail the compile. Cool. So we can make sure that need all that all ensure all something like that. And we'll just say that these have to be greater than 1. And we'd say, oh shit, I'm missing one. Oh, we're missing dragon. So we're gonna let's put 3 of them in there. Boom. That works. Cool. So we can check this at compile time now. Nice. Initializing a const expression standard array. Oh, true. I also didn't even make it const expression. It will deduce how long it should be. Well, even if it's not const expression, no? If less are provided than there should be. I don't think... Oh, well, I guess the point is that we should always make standard arrays const expression. That's the point. Because standard arrays... Well... Oh, that was the point. When we want to change the values there, then we should probably use... Well, should we? If we want to resize it, standard vector for sure. If we don't want to resize it, standard array for sure. But const expression standard array, that has to be when we don't want to change the values, huh? That feels like you could have a case where you have a standard array and you want to change the values and you're not going to resize it. Like if you had one of each Pokemon, or we had these limited number of Pokemon types, we want to change how many of them are present in the world, because if a new Pokemon's born and it's a metal Pokemon, there's a new metal Pokemon. Increment the index for metal Pokemon, right? If less initializers are provided than there should be, it will be shorter than expected. But that goes either way. The point is we can now just do this at compile time. Like if we had a standard array of unique IDs, and because let's say I have a company and I have 50 people in the company, and we have an enum and it goes all the way through from 0 through 49 and then 50 really to make sure that it's we can check to make sure that something is that number or is less than that number, so that we can loop through it, or we can verify the size. We could have a standard array of the specific values of each of those enum people, like this case, for example, for south part, and then we could do a static assert on that array. Boom. To make sure that, hey, how many people do we have now? Oh, we have whatever, this number. We put in an extra enum in here, and this value gets updated automatically because it's the last one. So if we put in a new enumerator, not new enum, a new enumerator, this value updates, which means, oh shit, if we added somebody in here, we added Butters here. Well, if we forgot to add this array, example, 4 elements, boom, it's too few. Only thing is it won't tell you which one you're missing. That's kind of annoying. But I mean, it couldn't. How's it gonna know? They're undefined. They aren't named. Yeah, and if we're accessing, well, the point here is we didn't put Cartman in. But then we put Cartman in, and then we tried to index it, or tried to add him, and we tried to access Cartman, doesn't work anymore. And it's because we have 6 total enumerators here. So 5 people, and we only have 4 here. So if we're accessing the 5th one, we're accessing Cartman. He's out of range. He's over here. But we can verify this at compile time now with static assert. Like, you're updating a map in Dark and Darker, and you add in a new type of chest to the game, and you have 50 different maps, or maybe you have 4 different maps, but each one has hard-coded good versions, because you don't do procedural generation, you just have different versions of the map that you manually did to make sure that it's compelling and not broken, because for balancing purposes. So let's say you have 4 different maps, 10 different, let's just say 5 different, let's say 3 different variations of each of the 4. So we have 12 separate maps. Well, for each map, you can check in the map, assert that the size of the array, the chest array, which tracks how many of each maybe enemy type or how many of each chest type, whatever. So if you add a new enemy or you add in a new something, and it says, oh shit, the array of what's in our map, there are only 10, whatever. It would just fail. You know what I mean? Specifically, you have 10 different enemy types in your map. You add an 11th. Well, it's going to check and say, hey, there are 11 enemies here, and then the max would be 11 because it's 1 extra, because the first is 0, so this one is 11. It's off by 1. And we could check the size. Oh shit, your array of enemies in your world is only length 10 because you only had 10 enemies before. You didn't add this new one. And we can catch that. So then you can go and add in your fucking dragon enemy. And you could do that and check and run a check for each of your maps. So you could say, hey, my fucking developer, go and add the dragon to each of these maps in the right spot and balance it out, blah, 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 whatever. And I could have a unit test that checks. We run it, and all it does is it loops through each of the maps. And then for each map, I guess we could say the map is a class. I don't even know, but we'll say the map is a class, and it loops through each element of the array of maps and checks static assert. Hey, does it match? Does the amount of enemies in your array for each map match how many enemies there should be on each map? Boom. Yep, so we have 4 scores. Now we're static asserting that the amount of elements, the number of elements in test scores, is max students, which is 5. Nope, there are only 4. So it fails before we index out of range. Yep. Ensure 2 different have the same length. Yeah, so you could say, like what? Maybe there's a local representation and an online representation of each player. And whenever the game starts, you make sure that each server player has a local body. Or maybe you have like an array of the online users in the game, and then the array of how many actual player bodies are in the game. And if each player needs a body, and they're assigned one on start, and you find that those arrays are not, well, that wouldn't really work because that would be runtime. That would be an assert, not a static assert. Because people aren't going to be in the game at compile time. Or maybe they are, and you spawn them elsewhere and they just get possessed as people actually log in. So the players are already in the game. You already have 1,000 players, but they're not actual real people. They're just players that real people inhabit and possess. Now, if you add an enumerator and forget to add to your array, it will fail. Cool. Use the const expression arrays for better enumeration input and output. A const expression array for better enum input and output. Oh, meaning... Should we just switch? Better. Oh yeah, I don't even know maps, but okay, I have ideas here. So we could say to output. So we could say, oh yeah, instead of having separate constants, we can just put them all in an array, right? So we could say include array because we need standard array. We're gonna change this to string view. Bro, this goes fucking massive. Wow. This is going to the playlist. So we could say namespace enemy or enemies, and then we could say well, it can't be const expression. Well, could it? I don't think it can. I'm gonna start with const standard array, and it'll be enemy names, and it is orc, goblin, hobgoblin, ogre, dragon. Or we'll just say that's it. Okay? And we could have an enum enemy, and we have an orc, goblin, hobgoblin, and ogre. And then we could say standard string view, get enemy name, and it takes an enemy, and it switches on enemy, or it just returns enemies, enemy names, enemy. Right? Oh my. Hold, something like this. Hold on. Let me make this make sense. So you plug in an enemy. Hold, what's happening here? The type name is not loud. Oh, hold. Wait. Not, oops, sorry. Enemy. And first we make sure. And then this is max enemies, or max enemy value. And we static assert that. So this guy is 0, so this guy is 4, they're 4. We assert that enemy names, size, wait, hold, is okay, why wasn't it auto-populating? Enemy names. I don't like that. Okay. And so now this works. And we could say well, so we'll do that, and then we'll do these work. I just need to, oh, we need to be able to extract it. Okay, so we'll do stream reference, operator insertion, stream reference, output device, enemy, and then we could do oh wait. Oh wait, hold on. This is standard character, but standard character input. Hold on. This is operator insertion. This is actually an iStream reference, right? And an iStream reference. Aren't we doing, don't we do an integer? Fuck, I can't remember. I don't remember if we do an integer and then. I don't have time. I'll make this better in a minute, but we'll do. Fuck. No, I need to make it better now. I need to remember this. Don't we, do we take it in as a character and then I don't remember if we do like int x and then standard character input to x and then enemy is now assigned x and this is an enemy reference. Well, it's not an enum class. Oh, the point is enemy converts, but are you sure? Wait, hold on. Wait, okay, it's cool there. I think that's how that was working. And then we could just have what print enemies. And then what print enemies does is loops through the enemies. So it'll say for const auto reference enemy for enemies enemy names outputs get enemy name. Well, fuck. Hold on. These should really be objects. Well, no, if we could have a standard array of classes in each enemy. Each class has the name, so we could just do .get name instead of having to pass. Yeah, because this is kind of shit. Yeah, I really don't like doing it this way, but it's whatever. Fuck it. While I is less than enemies, enemy names, or well, it should be standard S size enemies, enemy names. And what we're gonna do is we're gonna say, I mean, the index should match it, right? So we could just say one get enemy name of enemies, enemy names, data I. Hold. Hold. Get enemy names takes an enemy. Oh wait. We don't even need to print. Oh wait, we do need to print it though. We need to print wait, why am I even using get enemy name? Wait, why am I using get enemy name? I don't understand why. Shouldn't this just be enemies, enemy names? At player enemy, right? What am I doing, bro? Some things we'd have to assert that this is within range, I think. Wouldn't we have to assert that? Were we, oh, I get, well. Yeah, we'd have to assert that this value is less than max enemy value. Assert that enemy, hold, that, and really we should do this before. We should say assert that x is less than max enemy value. I'm sure I'm not commenting now, but I wasn't supposed to continue the song. Well, no, let's just be better. Excuse me, I'm pretty sure this can't be const expression. Oh wait, fuck it, can. And then oh, whoops. Okay. Yeah, I was like, oh wait. Yeah, it's true. If we do that, wait, if we do this, it outputs which does, okay, I think you actually have to do it that way. Okay. Oh, and this isn't needed. Like that. I did kill the semicolon there, but okay. Little testing, little using an array to store the different value instead of having a different constant. So like a standard string ogre, standard string this, we could have all our constants in one thing and then have an enum to just index those constants. I mean, it's kind of cool. And if we do and then we could get an enemy from the user by having the enemy or the user type in the name, and then we just do a switch case and or no, I guess we just check if it equals. Oh, we do a for each loop, and we just check for each element. Well, I don't know what's better. We can't do a switch on the value. Yeah, there is no switch on the value. Like we'd have to do an if else, but instead we could just do a for loop for each name. Does what the user entered match this name? Nope, go to the next. This name? Nope, go to the next. Instead of having to have an if else, blah, 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 blah. That's cool. I'm going to do that next. I'm taking a break.